So on question number 6, we are given 6.1, list three disadvantages of wind power from our renewable energy systems. The disadvantages of wind power, it is actually dangerous to wildlife, especially birds. And also wind is not always available. It is not always where it is windy. The wind turbines are noisy and it has a high initial cost. Manufacturing, transportation, and installation is costly. And wind farms are usually located in far-flung locations. All right, so those are disadvantages of wind power. And 6.2, there is a solar plant that we are given with this information. We want to determine the amount of alternating current power, that's the AC power, all right, the amount that the plant will produce in 1 year in gigawatt hours, all right, given that this plant has a surface area, so we have a surface area of 8,000 square meters in a location where the in radiance is given the in radiance of 1.5 kilowatt per square meter. The performance ratio is given as 0.75 and the collector efficiency 0.2, given a collector efficiency of 0.2. The plant works for 8 hours a day for 320 days a year. In that year, 320 days. So we've got the time, 8 hours for what? 320 days in a year. So how can we determine in this case the alternating AC, meaning to say we must play around with the DC, all right? From the DC, try to have the AC. Remember, our performance ratio gives us that. From the performance ratio, it is E from the AC over E of what? The DC, which is the input. AC, that is our output. So that's, we can calculate if we have this one, the DC, because we have got the performance ratio, but we do not have EDC. So EDC, that is from our DC, how can we obtain that? All right, it follows that. Remember, we talked about the solar power, that is the DC, it is from the solar. The solar, the input is what is the solar. So the solar power is simply equal to the E out over the time. Which is our DC, not out, guys. Where am I taking out? This is the input. The DC is our input over what? The time. So if we had the solar power, we are simply going to use it and calculate the EDC from there because we have what? We have the time already. So we need the solar power. That is why we are given these conditions, the surface area, this and that. Remember, for that PV system, the solar power can be calculated from the area times the value of our G, which is our irradiance that we are given, and we're gonna have the collector efficiency and our performance ratio. Remember, we talked about a formula, this one, yes, in kilowatts. So that's what we simply needed, this condition as it is actually. So the solar power can be calculated. So our solar power was going to be the surface area in square meters, 8,000. The G value, 1.5, that's kilowatt per square meter. So the answer is going to be in kilowatts. Our answer is going to be in kilowatts for the power. Efficiency 0.2, the PR value 0.75. So we are going to have the solar power of 1,800 kilowatts. 1,800 what? Kilowatts is our solar power. Thus, we can have from there, because we said we're gonna need what? This EDC, the DC from that solar power, because that is needed here. So we saw that our EDC is simply gonna be the solar power times what times time, if we make it the subject of the formula. So that's the solar power, 1,800 kilowatt. These are kilowatts. The time, it's 8 hours times how many days? 324. The number of days, we're going to take this in hours times number of what? Number of days here. So remember, this is in kilowatt. So whatever that we are going to have is going to be in kilowatt hour, time in hours. So we're going to have 4608000 like this, which is kilowatt hour. All right. So you can convert this one to gigawatt. Kilo, that's times 10 to the exponent of what? 3. And giga to the exponent of 9. So to have to the exponent of 9, we must have to the exponent of 6. 6 plus 3 is 9. So this is going to give us 3, 6. So this one, we convert it to times 10 to the exponent of 6, 4,608 times 10 to the exponent of 6. All right? Times 10 to the exponent of 3. So this will give us a giga. So that's a giga, 4,608 gigawatt. All right, so that's gigawatt hour. So that's the DC. So having the DC, the AC can be what? Can be obtained, remember, from our performance ratio. Like I said, so we're simply going to need the performance ratio from this, as we have got the DC, and we're going to find the AC, because here the question was what? To find the AC. So AC is going to be simply cross multiply here. So EAC is equal to what? E for AC is going to be simply the performance ratio times EDC. All right, so that's it. So in gigawatt, yes, they said what? In gigawatt, in gigawatt hours. So already here we've got the gigawatt hours from our EDC. So our answer is going to be in gigawatt hours from this one. So that's it, our performance ratio. Remember that was 0.75 times this EDC in what? In gigawatt hours already, 4,608. So that was going to give us 3,456, which is what? Gigawatt hours. So that is basically what you can be given. This is a typical exam question, as we can see. So it is just a matter of working out more question papers as part of your revision. Try to do as many question papers as you can. But that is it for now. That is it, guys. We are simply going to consider more of these revisions as time goes on. But for now, that is it. That is it. That is it from what we're given till we meet again.